Alright, so whoops, get that out of there, close that. Section 1.3, exercise 38. Now we're finally getting into more interesting problems. You know, in math, when we say more interesting, it usually just means, oh, they're harder. And we're told that the limit as x goes to c of f of x is equal to 2, and the limit as x goes to c of g of x is equal to 3/4. And then we're asked to find these various limits. And so here they're just asking us to use these properties of limits. So for instance, in A, we want the limit as x goes to c of 4f of x. But I can just factor that 4 out, so that's 4 times the limit as x goes to c of f of x. But I know that that limit is 2, so that's just 4 times 2, which is equal to 8. B, f plus g, so the limit as x goes to c of f of x plus g of x. That is equal to, probably should have, let me write it here, b, the limit as x goes to c of f of x plus g of x. Well, again, properties of limits, I can break that into the limit as x goes to c of f of x, as long as those limits exist, and they do, we're told that, and the limit as x goes to c of g of x. And so that's 2 plus 3/4, and so I can write that as 2 3/4 or 11/4, which I guess I would prefer that, or 2.75, something along those lines. C, we have f times g, the limit as x goes to c of f of x times g of x. And again, I can use my property that as long as those limits both exist, which we were told they do, I can break this up this way. So g of x here, x goes to c, and so I get my 2 times my 3/4, and so that's 3/2. And then finally D, the limit as x goes to c of f of x over g of x. And again, you know, the only time this is going to be a problem is if the limit of the denominator is 0. Then I wouldn't know what the answer is. But since I know that the limit as x goes to c of g of x is not 0, it's 3/4, I can again just break this up as the limit as x goes to c of f of x over the limit as x goes to c of g of x. And so that is 2 divided by 3/4. I'll invert and multiply, and I get 8/3. Okay, so there we go. A, B, C, and D for number 38.